Hi everyone, today we're going to illustrate the pathway of bacterial transmission that would cause bacterial meningitis. Meningitis is a life-threatening disease that are characterized by the inflammation of the brain and spinal cord. Meningitis can be caused by virus, fungi, or bacteria, but here we'll only focus on bacteria infection because it has remained by far the most life-threatening disease in the world. Our model is based on the conservation principle of mass, and we treat each organ in our system as a bioreactor. So according to published literature, about 10 micrograms of bacteria enter our body through nasopharynx, or known as nasal cavity. Of those bacteria, only about 8.2 micrograms could penetrate the mucosal membrane and could continue to be carried by the bloodstream, while the rest of them are typically trapped by the membrane. And as everyone knows, blood circulation system can be very complex and intertwined. Therefore, about 1.6 microgram of the bacteria could be carried to the wrong target and can promote the infection inside the brain. And based on several literatures, we found out that it typically takes a bacteria a total of 15 minutes to enter the cerebrospinal fluid. So we applied the differential equation of the conservation principle and calculate the flow rate of bacteria into the CSF to be 0.427 micrograms per minute. Using a similar fashion, we calculate the net growth rate inside the CSF to be 7.76 times e to the 0.00035 microgram per minute. And the net growth rate is calculated as the growth rate minus the death rate. There are several important assumptions in our project. First, we use mass accounting equations that are algebraic and differential for different systems. The huge system is defined as the human body, in which we assume it to be open and steady-state system, and also we consider the human body as a huge bioreactor. The system boundary is defined as the skin of our body. For the pharynx and bloodstream of our system, we use the algebraic mass conservation equations, and we assume that there are no generation or consumption terms in these subsystems. Finally, for the CSF, we assume that there are no reaction occurred of bacteria in the CSF, and no bacteria leaves the system after the neuronal damage they trigger.